Hello, this is part 2 of factoring polynomials using rational zero theorem and synthetic division. So the direction says factor polynomial completely, you do not solve. So let's see here. So let's figure out our p. Our p is usually the constant and it's always positive, so it's going to be 9. And what are all the factors of 9? Plus or minus 1, 3, and 9, right? And then we got to figure out our q. Our q is actually 3 because it's the coefficient of the highest power. So our highest power is 3, but the coefficient of that is 3. And then all the factors of 3 are plus or minus 1 and 3, correct? And then we're going to do rational p over q. So that's plus or minus 1 over 1 is 1. 1 over 3 is 1/3. 3 over 1 is 3. Right? 3 over 1 is 3. 3 over 3 is 1, which we already have, so you don't have to redo that. 9 over 1 is 9. And then 9 over 3 is 3, which we already have. So you have a possibility of 1, 2, 3, 4, 8, right? Because of this minus, it's really 1, negative 1, 1/3, negative 1/3, 3, negative 3, and then 9, comma negative 9. Okay, so you have a total of 8 choices, and then we're going to do synthetic. So I always check if there are polynomials in order. If we're missing a power, replace it with a 0. So are we in order? 3, 2, 1, constant, right? Yes, we are in order. So it's going to be 3, negative 19, 33, and negative 9. And I'm going to use, so what should I use? I'm going to try 3. You're just going to have to, like I said before, you have to just choose one. If it remains, there's no trick, just choose one. If it gives you a remainder of 0, that means it's a 0. So yeah, it is tedious. So first, put a placeholder under 3. So 3 plus 0 is 3. Then you multiply 3 by 3, which is positive 9. And then add these terms. What's negative 19 plus 9? Negative 10. And then negative 10 times positive 3 is negative 30. 33 minus 30 is 3. And then 3 times 9 is positive 9. Okay, so factor. So 3 is an actual solution, but in factor form, it would be x minus 3, right? And then do you see these numbers? These are your coefficient of your new equation. So it's going to be 3x, and then we're no longer going to use the power 3. We're going to use 1 less. So it's always 1 less from the highest power. So if our highest power is 3, 1 less of that is 2. And then you just keep on going down. So our next coefficient is negative 10, x1, and then 3, right? So we want it completely factored. So this right here can be factored again. How can you factor this? You can either, there's 2 options. You can, or actually 3. You could do bottoms up. You could also do quadratic, or you could also do synthetic and rational zero theorem, the same process as this, right? Let's see. I think I will try bottoms up if it works. So first step is rewrite as if the 3 doesn't exist. So it's going to be x squared minus 10x. Then what you do is multiply the 3 by the last term, which is 9, positive 9. And I do believe this does work. So from here, you just do regular simple factoring. So you need an x and an x. And then two numbers that multiply 9, and when added gives you negative 10. Negative 9 and negative 1, right? That gives you negative 10 and gives you positive 9. Good. Then remember, with bottoms up, you have to divide the negative 9 by 3 and then the negative 1 by 3. And then this simplifies, right? Negative 9 divided by 3 is negative 3. Over here, negative 1/3 is a fraction that cannot be reduced anymore. So what you do is you put 3 in front of the x. So that's 3x minus 1. See how the x minus 3 repeats. So what you can do is rewrite it as x minus 3 squared. And then later on, when you're learning about graphing polynomials, you know that this has a multiplicity too, which literally bounces on the x-axis. Okay, so they want it factored, not solved. So this is your final answer. Okay, go ahead and write down. Go ahead and pause and write down all the work. And I'm going to do the last example. Okay, so example 4. So same directions, factor completely using rational zero theorem aesthetic, do not solve. So let's first figure out our P and our Q. So my P is going to be 8, because it's always the last term. And then all the factors of 8 are plus or minus 1, 2, 4, and 8, right? And then now we're going to do Q, which is 3. And then all the factors of 3 are plus or minus 1 and 3. So rational zero theorem is P over Q, which is plus or minus 1 over 1 is 1. 1 over 3 is 1/3. 2 over 1 is 2. 2 over 3 is 2/3. Okay. 4 over 1 is 4. 4 over 3 is 4/3. 8 over 1 is 8. And then 8 over 3 is 8/3. Do I have anything that repeats? I don't think so. Good. So you have, this is a lot more. You have 1, 2, 3, 4, 5, 6, 7, 8. You have a total of 16 possibilities, 16 possible zeros. So now we're going to do synthetic. Check if this is in order. 3, 2, 1, constant. It is, so we're just going to use the coefficient. And I have, you're just gonna have to pick one. What should we use? Okay. Let's try 2/3. Or how about negative 2/3? So I think because I did put it in a graphing calculator to save us time, you literally just got to pick one, and unfortunately, there's no trick. So placeholder under 3, 3 plus 0 is 3. 3 times negative 2/3 is negative 2/3 times 3. The 3's cancel, so you're just left with negative 2. Negative 4 plus negative 2 is negative 6. Negative 6 times negative 2/3, so that's negative 2/3 times negative 6, that is 12 over 3, which is 4. And then 8 plus 4 is 9, 10, 11, 12. And then 12 times negative 2/3 is negative 24 over 3, which is negative 8. And as you can see, it works. So, okay, so if negative 2/3 is a solution, how do I write that as a factor? I think you're going to write it as, I think it's 3x plus 2. Yes, because if you set 3x plus 2 to 0, right? So solve for x. Yes, that definitely could be negative 2/3. And then these are your new coefficient. So this is 3x squared minus 6x plus 12. How are we to factor this? There's one thing I noticed, you can take out a GCF, right? Yeah, I think you could take out a 3. So take out that 3, put it all the way to the left. And then this was going to be x squared minus 2x is 4. And over here, can we factor this anymore? We could try simple factoring. Yes, I believe we can do, no, we can't. I think this might have to be prime. How can we factor this? X squared minus 2x plus 4. I mean, if you use 2 and 2, that won't work. If I use 4 and 1, that'll never give you negative 2 when added, right? So let's see if it actually is factorable, meaning it's not imaginary. So how can I do this? I could try a quadratic formula. A equals 1, b equals negative 2, and c equals 4. If it gives you an imaginary root, then we'll just leave it as that, because that means these are roots, so it can't be factored. So let's see, x equals, so I'm using quadratic formula, x equals opposite of b, which is 2, plus or minus root b squared, which is 4, b squared minus 4 times a, which is 1, and c is 4, all over 2a. 2 plus or minus negative 4 times positive 4 is negative 16. Yeah, this is definitely imaginary, right? Because 4 minus 16 is going to give you a negative power, a negative number, and that's dealing with imaginary. So I think we'll just leave it, that is prime as can be, so we'll just leave it as that. So this is the most factored it can be. So when you find your actual zeros, one of them is going to be real, right? This one is going to be real. And then you have 2 more roots, but they're imaginary. So 1 real, 2 imaginary. So you'll learn more about that when you learn about graphing polynomials. Okay, so yeah, go ahead and pause, and I'm going to end it here. Thank you.